So as Sadia mentioned, among us today, we have representatives from almost all of the famous computer vision open source projects. So we'll cover a lot of interesting topics that, behind the scenes of what it takes to build and maintain these popular open source projects. But I want to take us back to the very beginning to start this off. So my first question to start off this panel would be, how did these projects first get started? Let us start from the very inception and cover the journey to the very first release. These projects sometimes start as as student projects or just internal company projects, and or sometimes you just see gap in the market and you realize it's something that our product can fill. So there's different stories behind all of these projects. So I just want you guys to take us to the very beginning, and let's start from there. So on my screen, I see Yin Shi. So let's start with the PaddlePaddle team, and then we can go from there in round robin fashion.
Okay.
Over to you.
Yeah. So actually in Baidu, we started to apply the deep learning technologies very early, and maybe 2012. And deep learning was applied to our search engine system to improve the relevance in 2013. And at the meantime, we started to develop the deep learning framework. And the deep learning framework, namely PaddlePaddle, was open sourced in 2016. And after several years development iterations, our recent PaddlePaddle releases the version of 2.3. And during this whole process, deep learning technologies and the PaddlePaddle framework are widely used, not only in the Baidu internal businesses, but also many different areas, and also be applied by many different companies, maybe in computer vision and natural language processing and speech recognition and etc. And that's how our project started. Yeah.
Perfect. Yeah. Next, I think we have on my screen Bo Zhang from Meituan. So, yeah.
Okay, so actually, object detection has been continuously thriving since the release of YOLO. And we see that from the industry side, we have the stringent requirements. We see this opportunity to refurnish the single state detector to accommodate the most recent advances in architecture design, and also in domain improvements from academia and industry. And PPLAE and UW6 are very close projects going on at the same time. All three projects were started privately until the public release, and we are actually bringing the UW6 to reality. So we see that there is huge peer competition, and we see that most. Yeah, basically it's from the requirements that we have, the scenarios that in Meituan, and also this trend in architectural design. To put in detail the reparameterization trick, we think this is a very fashionable design to shape the future of architectures in networks. Yeah.
Great. So I think Wanzhong Wang wanted to talk about paddle detection, and then we'll move on to MMLab team.
Okay, sure. Yeah, actually, I introduced the paddle detection and our YOLO series models just before, and I just want to talk about how we started to do such things. And in the very beginning, the paddle, as Yixin mentioned, was implemented for search engine system in Baidu. But it is not proved in other fields related to deep learning, such as the computer vision. But that was the largest demand in the real applications. So we started to build lots of algorithms in many scenarios like the object detection, classification, and segmentation. And those kind of models could not only support the business, but also enhance the ability of PaddlePaddle. Yeah, and for example, we implement the fast RSN and mass RSN, and we develop many operators for our PaddlePaddle framework. And these models are also treated as important benchmark now for PaddlePaddle to optimize.
Great. MM Lab team, and then Glenn.
Okay. So basically, the project of Open MM Lab starts at the 2018. Yeah. So after the team won the first prize on the cocoa detection challenge. So at that time, you may see that people are still using like Cafe and Torch, and the PyTorch only release its alpha or beta version. So basically, in object detection area, people are using Detectron, and it is very hard to install the environment if you have tried that. So it also took the team a lot of time to re-implement Mask RCN. So after we won the first prize in the challenge, and we know that the community also struggles about re-implementing the algorithms. So we decided to release our code, and then we release MMDetection and MMCV. And in MMDetection, we re-implement many detection algorithms like RetinaNet, Mask RCN, and Cascade RCN system. Yeah, that's how we start the project.
Great. Glenn?
Yeah, so I took a bit of a different path. Ultralytics was originally founded for particle physics work. We did this with the US government, with some intelligence agencies, and we started getting into artificial intelligence as one of the solutions we were doing to reconstruct particles in detectors. So we were looking at antineutrinos, gammas, neutrons, and we need to know where they're coming from and what their energies are. And so we built regression models to figure out the solutions. And those worked really, really poorly. And the reason was we simulated data that we trained on, and then we deployed it on a real world detector. But that's where I got my interest in AI, and in particular vision AI, because vision AI was really similar to the particle physics detectors we were doing. And I started looking at YOLO in particular, and this was right when the original YOLO v3 authors had left. So Joseph Redman and Ali Farhadi had split ways, and there's nobody really manning the YOLO ship at that point. It was sort of a community effort to keep the research going. And I think my main contribution was kind of simplifying YOLO. So it was written in Darknet, which is a C framework, which is pretty complicated. I knew some C, but it wasn't the easiest to work with. And I wanted to port that over into PyTorch, which seemed much more friendly and more Python friendly. And so that was my main work. And it was really sort of my own personal project at that point. I wanted to simplify it so that it would be usable for the experiments I wanted to run. And this was also the first opportunity I got to open source my work. When I was working for the government, they didn't like that. So it was all secret and private. But now on the open source side, I started to notice a few benefits. People would come and they'd pitch in some help, they find bugs, and it sort of became more of a community effort at that point. And so originally I didn't have big ambitions. I wasn't trying to launch a big product or anything like that. I was simply trying to reproduce the work that was out there, make it more simple, easy to use, and that's really how I got to where we are today. So.
Great. Yeah, I think the general consensus here is that people were trying to solve their own problems or maybe problems of their teammates, and then they built tools that they thought that could be used by the world, and then they open sourced it, and then they became really popular. So that's the general consensus here. All right, so
seems like it.
Yeah, the next question that I have is, like, I've noticed this generally with a lot of open source projects, is that when they start out with the community contributions and feedback, they sort of evolve over time, right? So they maybe change directions or maybe focus on a particular area more than they did at the time of the launch and things like that. So the next question is, how did community contributions and feedback evolve the project over time, or did it evolve the project over time? So, I mean, yeah, we can start the same way first with PaddlePaddle team.
Yeah, so actually, as the first open source deep learning framework in China, Paddle has encountered lots of difficulties and resistance on the road of open source, since people are not familiar with the concept of open source and they don't know how to participate, and they lack of the interest to contribute. So at the very beginning, we almost start the whole development mainly by our own, and under this kind of environment, at first we started to improve the maturity of our project, and at the same time we started to do some work to promote the concept of open source and make people familiar about the PaddlePaddle, and both in maybe online and offline ways. And for the offline ways, we will organize and hold some activities such as the interest group discussion and some open source seminars and etc. And through those kind of face-to-face in-depth communication, I think more and more students, even for the developers in the enterprises, they are attracted by this project, and they are willing to try to use the PaddlePaddle. And for the online ways, it is easier for us to reach more people at one time. So we started to make some universal promotion activities, such as the live streaming like today, and we will publish some online articles, and so that more people can learn about the open source and understand the PaddlePaddle. And after the number of our users accumulated and increased, and we found that more and more people will contribute to our project, such as we will receive some pull requests from them. And then we also will hold some activities such as maybe model implementation competitions, and in order to improve the enthusiasm of the developers to contribute, so that the whole open source community is become more warm up, I think. Yeah, and as the product become more mature and the developers become more familiar with the open source contribution method, more developers will participate and expand the influence and finally generate some very positive effects.
Great. So Ron, John, do you want to add something about paddle detection?
Okay, starting from YOLO 6, I think we have been, it has been the first time that we release in open source. It has drawn much attraction, and a large volume of pull requests have been merged from the community, especially the handy features from like porting to different languages and devices for deployment. And there's so many fancy demos that are going on, from like Hugging Face and etc. And we were not expecting, actually at the time when we published the first release, we were not expecting so much traffic and so much traction that we cannot even handle that. So on the first few weeks that after the first release, we were doing a lot of bug fixes, and there was some validation around custom data sets, and we were kind of, at the time, it was so busy doing that till day and night working on the bug fixes. So the feedback from the community is not just technical. I think it's a reconfirmation of the mission of our project, and the whole team feels so obligated as much as privileged to make YOLO 6 a great project. Yeah.
Great. Yeah. Ron, John?
Yeah, so initially the project is, this is a project of several PhDs in the Lab from the CUHK and the NTU. Then we start to collaborate with the community's researchers and the developers. So basically in the MMDetection V1, we invite the paper authors to re-implement their algorithms in MMDetection. And then we find that the whole community start to contribute the algorithms and give suggestions about our design. And they will go through docs and codes and maybe initiate discussions in issues. And we take the feedback into our new design. So basically each major upgrade from the MMDetection 1 to MMDetection 2 to MMDetection 3. So each major grade, they takes many vital feedbacks from the community. And since the MMDetection 2, we got more and more contributions from the community. Yeah.
Great. Paddle detection, and then Glenn for YOLO V5.
Okay, so yeah, actually, you should mention a lot about how the PaddlePaddle this project evolved through the community contributions. And I would like to share something about the paddle detection. And actually, there are a lot of tutorials and courses are made by the community contributors. And actually, they helps us a lot because the more the contribution and the more tutorials we have, we could attract more people to use our models or algorithms. And besides that, we also there are some actually apps like a small object detection apps and a key point detection apps. Yeah, they are all made from the contributors. Yeah, and actually we thank them a lot, and we hope that there could be more and more contributions. And yeah.
Great, Glenn.
Yeah, so let's see. So for us, open source was definitely a new thing. So like I said before, we were coming from government projects, and the open source side, like initially, we were like a little worried everybody would run off with our work, but then we quickly realized that the opposite was true. So I think when you develop in private, you don't really run your code through a lot of edge cases, but when you put it out there for the world, everybody downloads it and they start using it in ways that you had no idea that they would use it, taking it to places that you'd never thought. And this means that they're going to break it. And that's actually a good thing. It's really a great thing. It means that the more people break it, the more you fix it. And then the more you fix it, the more it becomes more robust, better maintained. And I think this is the real advantage. So even though we have a really small team, there's a big community out there. And we've had hundreds of contributors come in, and a lot of course, like people really like to specialize in one thing. And since we have a small team here at Ultralytics, we're not good at everything. Like for example, we're not very good at TensorFlow, but some users who are experts at TensorFlow came in and helped us set up TensorFlow exports. And so now we can go to TF-Lite, TF-Save models, protobufs, all these things. And we never would have been able to do that ourselves. So we expand the market, the product's better tested, more maintained, and there's more features. And so it's a bit of a snowball effect. Like we talked about the last question, like when we first started, we were just trying to create an internal project, nothing more. We didn't realize that this was really going to kind of like get really popular. But as it has, the benefits have been growing, and it's really a virtuous cycle, I think.
Great. So yeah, general theme is here that there's a great advantage of building in public rather than in private, because we get instant feedback from the users, and if there are some bugs, we just are able to fix them much more quickly. So I want to cover something a bit light here now. So I'm pretty sure like these projects have been really popular for a number of years. So you must all have had some memorable milestones along the way, right? Maybe some big feature launch that really made a project really popular among users, or something like that. So I would like you guys to share some of your memorable milestones along the way for these projects. Again, the same order: PaddlePaddle team, paddle detection, and then we'll cover other people as well.
Okay, actually, to be honest, PaddlePaddle grew really, really fast in the past 3 years, and each year has its own goals and theme, I think. And in 2020, as the first deep learning open source framework in China, we hope to initially form some unique features. And we have observed that there is a huge gap between the deep learning framework and the real applications. And we so since then, we started to build up some toolkits such as the paddle detection, and in order to shorten the research and develop time of the AI project. And in 2021, our theme is to build a unified design of dynamic and static graph mode framework. And in this year, our framework released the version of 2.3, and to support 2 programming paradigms. So the developers can use the dynamic graph to develop the models, and then they can only use one line code to convert it to the static graph mode, and in order to just deploy the models in different environments and devices very efficiently. And in 2022, we focused on the hardware adoption and build some tools to serve enterprises and the universities better as a deep learning framework. And in this way, we attracted more and more different developers to participate and contribute to the PaddlePaddle so that the AI can be empowered all walks of the life. And we are looking forward to more industrial applications can benefit more from the PaddlePaddle.
Yeah, and for paddle detection, actually the most memorable moment is that we open sourced the first time, and 2019. Yeah, and at the time, actually, the paddle detection only include some basic object detection models. Yeah, but as a development case, there are many people who are interested in this repo, and as a researcher or developers, it's a happiness to see that the code you write are used by so many users. Yeah.
YOLO v6.
Okay, so since the initial release, we actually published only lightweight models like small models and nano models, and lots of features requires to be improved and complete. There's some negative comments going on, and the team spirit was quite low at the time, and we were worrying so much, but we see that the community started to continuously confirm that YOLO v6 is actually working their cases. And some wrote to backs up on GitHub issues, some uploaded very cool videos on YouTube. So we were actually feeling that was the tipping point for the team to shake off the pressure and restart all over again. And we're empowered with positive expectations from the community so that the whole team was moving forward for the second release. And the second release is another milestone. And there were lots of debates going on internal and discussions, a lot of experiments, like burning all the GPU cards that we have. And yeah, benchmarking all kinds of data sets, and a lot of code reviews before that. Everybody was working day and night. And I think that the whole team, it's actually the Beijing team and the Shanghai team. We have two teams working remotely and to find the best solution, and especially under very tight schedule. We were actually wanted to release before September, but a little bit delayed, but we came to release to bring the YOLO v6 large models at the second release. So I think the second release and the first release are a challenge for us, and also a way to give the whole team a lesson to really incorporate and to have good expectations other than negative, not to be influenced by the negative remarks. Yeah.
Great. MMDetection.
Okay, so the most memorable milestones is the release of the MMDetection v2. So at that time, the development team of MMDetection only contains 4 people. But the 4 people, they are in 4 places, including Singapore, Hong Kong, Shenzhen, and California. So we work really hard at that time, actually, and basically the commit frequency and the code changes is very large, and it is even not surpassed by today's commit histories. Even we have basically more peoples. But no matter where we are, we make the MMDetection v2 release. And that version has many very exciting features, and that we feel proud of. And it is MMDetection v2 that really makes it a kind of library or platform that can support projects like MMDetection 3D and many other libraries. Because before that, people usually use MMDetection from source. Basically, we fork a repo and we just modify the code bases, and we do something or do some research. But now we could use it as a library like the PyTorch since the MMDetection 2. So it is very memorable. Yeah.
Great. Glenn?
Well, I'd have to say, I think the most memorable event for Ultralytics was probably the YOLO v5 release and a lot of controversy that came after it. And so we also had to sort of like ignore the naysayers, ignore the critics. And I think the most important thing was that we sort of stuck to the mission to keep improving. So we responded to the feature requests, to the bug reports, and really put in the effort there to keep improving it and keep addressing like all the issues that popped up with the use cases that we couldn't have anticipated. So there's a lot of work leading up to that. YOLO v3 was our first effort, and that was about a year, like a whole year of just getting up to speed, reproducing darknet results, running experiments, improving. And I think the YOLO v5 release was really the culmination of all of that coming together. But of course, it wasn't a single event. You know, with open source, it's never done. And so the release is just a point in time, but it really just marks a date on the calendar. And the work was going on before it, continues after it. So.
Great. So initially, the responses about like the initial launch. One of the main things that I saw was that the focus was to simplify things when building these libraries. Initially, it was very difficult to build or install the dependencies for a particular task or a particular library. And the general theme here is that all of these open source projects have simplified the process of installation, setting up, and so the access to these tools have improved. Now, I have the question the next question along these lines. So there are times when you cannot build everything from scratch. So you have to depend on external dependencies, external libraries, and things like that. So what are some of the things or some of your checkboxes or any other particular characteristics of these external libraries you want to verify you take a look at before adding them as dependencies or using them as dependencies in your own tools? So yeah, let's start with PaddlePaddle and PaddleDetection.
Yeah, I think this question may be easier for Guanzhong just to use the PaddleDetection as an example and to explain you guys about how we choose the external libraries. Yeah.
Yeah, I would like to answer this question in the view of PaddleDetection. And for external library, we always keep three principles. First one, the license agreement. Yeah, actually, the license matters in open source environment. And if there is any conflict on that, we may consider to change another library instead. And secondly, the function in this the library should be necessary, and the function have to be complete and irreplaceable. For example, in the object detection field, the COCO API and the MOT matrix are the third-party libraries to evaluate the model in object detection and multi-object tracking, and which could reduce the amount of code by a large margin. And finally, the library should be installed and assembled to our code base easily. And besides, we need to check the version of external library carefully to adapt our code. And we also prefer to choose the library that covers different systems like the Windows or the Linux. Yeah.
Awesome. Over to YOLO v6.
So in the YOLO v6 project, the main point is whether we find that the external library is the best fit for the project, considering all the available options. It shall be easy to use, and we think whether it's robust and efficient in our project. We also check whether it is open sourced and stable and actively maintained. Basically, we adapt all the available libraries that we use in all YOLO families. Actually, we just put, this is a line of libraries that we share in common. I think in all YOLO, like COCO API and so on and so forth. And I think all the libraries are quite common for object detection. So yeah, basically I think we share a lot in common for the whole YOLO family projects. Yeah.
Perfect. MMDetection.
Okay, so as they mentioned, firstly, the stability. So basically, we will check the code base or the project and see how well and how regular it is maintained, and whether it is stable. So that this project have many bugs to fix, or do they have any roadmaps? And we will also check its functionality. So for example, whether this project meets all demands, or sometimes and we need to compare different external libraries and to compare the advantages and the disadvantages. So for example, about the config libraries, so we have the YAX and we have the YAML, or we have the Python configs and like the Omega config. So we need to compare different libraries about its functionality and then compare the advantages and the disadvantages. And we will also consider its popularity. So basically, of course, if many users and developers use this project, we will also be very interested in them. So yeah.
Awesome. Yeah.
Yeah, so we've had an interesting journey on this side. As the project's grown, the list of requirements has also grown, much to my dismay. So our first approach is not to add additional dependencies. Every dependency you add has its own dependencies, which may create conflicts. So one package may have sub-dependencies that require certain constraints, which conflict with another package. And we've seen this happen, especially on the export side. So we support so many export formats now that installing all the packages at the same time often leads to conflicts. And so we've taken sort of a unique approach here. So rather than install everything at the same time, we sort of install things on demand. And this has come up from conversations with users. So for example, if we introduce a new export format, like we just actually introduced just PaddlePaddle just about a few weeks ago. And if we put that in the requirements, maybe somebody just wants to export to Onyx and they'd say, well, why do I need PaddlePaddle in here? I'm not using it. And so a lot of users started asking questions like this. People get upset because they don't need these components that are sort of specialized. And the approach we've taken is something called auto update. And so we have base requirements, things like Torch and NumPy, which has been mentioned, really we all share. But for more specialized things that not everybody uses, things like maybe CoreML or Onyx or OpenVino or PaddlePaddle, we take a look before a command is run. We take a look at the requirements that are necessary for that command. And then if they're missing from the operating system, we'll simply install the package. And so this is, it's a little, I guess, it's a bit innovative, maybe slightly controversial also. But we found that users really like this because oftentimes if they're missing something, then it'll be installed for them automatically. And it leads to kind of more correct solutions the first time without them having to take a second step of installing and then a third step of rerunning. So our approach is basically to avoid dependencies. But if we need them and if they're not core to the operation, like if they're simply not part of training and inference and validation, then we'll probably auto update them on demand if they become necessary.
Awesome, great. So the general theme here is that the project should be stable, actively maintained, and if it's popular, it's a big bonus. So yeah, so I think this might be our last question. So I want to take this question back to the community interaction. All of these tools that we're building are developer focused. So one of the best ways, one of the most popular ways or most frequent ways the users will interact is through the tutorials, through the wikis, through the docs. So what is your strategy to go about for the docs? Like how often do you update it? How do you decide whether a particular section of a tutorial is needed? Whether it's like the number of user demands coming in for a particular feature or explainer for a particular feature or guides for those things. So yeah, general strategy behind addressing docs and providing more tools for community to understand the usage. Again, the same pattern. Let's start with paddle detection and PaddlePaddle team.
Yeah, actually, so for paddle detection as an example, so we usually release a new version each quarter, and each time we will review and update our documentation. And as you all know, the documentation is really, really important for our users. And since not only the students use the paddle detection, but also the enterprise developers, they will use paddle detection to apply into the real life applications. So so besides those kind of basic tutorials, we also will provide some end-to-end tutorials for specific scenarios, such as maybe the face detection, and we will provide the tutorial from the data preparation and the model building and model developing, and the how the model can deploy to the devices. And I think so we keep updating those kind of documentations. We try to only keep updating our documentations once in a quarter, but it's not enough. So maybe if we found it is there is a huge bug or something very serious, we will just to revise it very quickly, maybe in one day. Yeah.
And actually, we wrote our documentations in the paddle detection manually now. And I just want to say something about paddle MM detection. And we found that MM detection released many documentations from community developers about algorithm analysis and how to develop on their framework. Yeah, I think that is a great way to help more users to learn object detection and their repo. And in PaddlePaddle framework, actually the documentation could be generated automatically according to the API comments using Sphinx. Yeah.
Sphinx docs, yeah.
Awesome. MMDetection.
Okay, so for API docs, we will require that each merged pull request should have a complete doc strings. So basically, the API documentation are always updated. And for the tutorials, sometimes actually we will always miss to modify some of them. So the community will help to correct. So basically, every week we will have several pull requests to help to correct the documentations and the tutorials in the projects. In the meantime, we have some developers from the community. They will help to contribute some new tutorials to the projects or in some social medias. So basically, these are updated based on the versions. So if, for example, the MMDetection 3 is released and it has many breaking changes, so we need to update almost all the documentations of MMDetection. That's what we are working on in the next quarter. Yeah.
Great. YOLO v6 and then YOLO v5.
Okay, thanks. I think documentation and tutorials should be kept as easy as possible. This is the biggest portal or the interface to users apart from the code. And so far we have written the user's documentation manually to provide a quick hands-off. And significant updates are provided on each release, and each feature has its own specific tutorial to follow through. And we update all the tutorials and documentations on a weekly basis, maybe more soon. I'm not quite sure, but we have collected frequently asked questions in a specific issue so that we can update what we have from the community. We come up with the relevant answers so that users will not be getting the dubious about what is going on and what the project is having the common features or common bugs. This is continuous updated, I think, on a daily basis. We keep tracking of all the users' comments and questions especially from WeChat groups. We think that those are quite instant. So basically, I think documentation, so far it is in a manual procedure, but I think there will be a automatic tool to sort it out. Yeah.
Awesome. Glenn?
Ooh, yeah, documentation. It's not my favorite. So my dream would be for one day, YOLO comes in a box like an iPhone, you open it, there's no instruction manual, you just know how to use it. But of course, we're not there yet, it's still complicated. And the users really love tutorials. So we've seen like the most popular ones are sort of quick start tutorials, how to just install the bare requirements, run one command, and say train a demo model or a really tiny data set. But that being said, documentation is one of our weak points. We got a really small team, and everybody's focused on building YOLO, fixing bugs, and introducing features. And there's not really any time left over for docs, or if there were, it would be time that we take away from actual R&D and building the actual product. So we've sort of had to pick and choose, and docs has been not on the winning side of that decision oftentimes. But like Guanzong mentioned, I think automation in the docs would really help here. So right now, I think we use MK docs, but introducing doc strings that Sphinx docs builds, I think would be a really good step. I think this is what Torch uses. And of course, this way, when you change the code, you simply change the comments in the doc string. And I think that would really kind of like help us out here. So I think that's one of the things that's on our to-do list. It's a long list, but it's definitely on there. It's our part of our roadmap is to improve the documentation.
Awesome. Yeah, that was the final question, like internal question for the panelists. Now I think we can take some questions from the participants who are attending this talk. So we have question from Gaith Al-Masri, if I didn't butcher his name. Since YOLO v5 is about to make deep learning ML AI easy for developers, would you ever consider implementing a system, a GUI, for example, to include users who are not developers or have zero background in terms of development?
This is a really good question. Actually, we have a talk that's coming up. So at Ultralytics, we only have two products. One of them is YOLO v5, but the other one is called Hub. It's called Ultralytics Hub. And we've been working on it all year. And it's exactly this. It's a no-code solution. It's an AI platform. You simply log in, you upload some data, or maybe pull it in from an integration like RoboFlow. You select one of the YOLO v5 models, and then you just click start training to train in the cloud. Or if you have your own hardware, you can train there also. So we're going to talk about that like a little bit later. But this is also sort of like the second phase of our journey. So as I've said it before, like my dream here is for my mom to be able to use YOLO. She can't use it right now. She doesn't know Python. So if you're not a developer, which is a much larger addressable market, then that's a big segment of the population that's out of reach for AI tools. And so I think it's really easy, really important for everybody to be able to use AI, not just I think like the most knowledgeable developers. Even if we just take a look at say like the AI developers versus web and mobile developers, there's about 2 orders of magnitude more mobile developers and web developers. And so if we can just kind of bridge that gap, we'll be multiplying the number of people that are using all our products by about 100, which is incredible. So I think that's really important, and it's something that we're working on, definitely.
Great. I don't think we have any other questions, but yeah, if anyone wishes to ask this panelist any questions from any aspect of their open source journey or about their product, please feel free to ask them right now. We'll just wait a minute more and then let's wrap this up.
I think maybe for me, the most interesting question is kind of like the longer term picture. Like maybe the near term's kind of well defined. We can do more R&D, use the same modules, maybe experiment with them. But say 5 to 10 years from now, like where's the direction of the technology headed, I guess? Like what's the next big breakthrough? So I don't think we're going to figure that out here in this call, but I'm not sure there's an answer to that.
Anyone wants to like take on this question? I mean, it's an open-ended question. So.
I think in research, there's like exploitation and exploration. Exploration is more about researching different directions. Exploitation is about just getting really good at what you're doing. And I think we're sort of in the exploitation phase right now for Vision AI. So the exploration might be a completely different type of technology. Some people might have thought transformers was that, but it doesn't seem to be substantially different than basic convolution networks in terms of the performance that we're seeing. So.
All right. I think it's time to wrap this up. So like, I'd like to hand over to Talia.
Yeah, thank you, Ayush. And thank you to all the panelists. This was really, really awesome. Again, we were so happy that you all could join today.